Right, today I'm going to be going over the trig IDs, and I'm just going to be doing the fundamental trig IDs. So you have your reciprocal IDs, and those are saying that the sine of an angle is 1 over the cosecant, the cosine of an angle is 1 over the secant, and that the tangent is 1 over the cotangent. So therefore, because you know this, you can also say that the cosecant of theta is 1 over sine. The secant of theta is 1 over cosine. And the cotangent of theta is 1 over tangent. Now you probably want to write these down and have them on maybe a whole sheet of paper called the trig ID sheet. And this is important because if you know that the sine of theta is equal to, say, 3/5, then you can say that the cosecant is 5 over 3. If you know that the cosine of theta is 4/5, then you can say that the secant of theta is 5/4. And if you know that the tangent of theta is 3/4, then you know that the cotangent of theta is 4/3. So that should be useful in some of your problems. Now there's other identities, the quotient IDs, which should also go probably on that same sheet I was talking about, where the tangent of theta is the sine over the cosine. And why does that make sense? Well, because we know that sine is our y value, and we know that cosine is our x value, and we know that tangent is y over x, so therefore this ID should make a lot of sense. Therefore, we can conclude that the cotangent of theta will be the cosine over sine. So these should go on your sheet under quotient identities. Lastly, we have some Pythagorean identities. And if you have an ID sheet, these should go on it as well. The first and probably the most predominant Pythagorean identity is the sine squared of an angle plus the cosine squared of an angle equals 1. I use that one all the time. The next one is 1 plus the tangent squared theta equals the secant squared theta, and then 1 plus the cotangent squared theta equals the cosecant squared theta. So how do I use these? Well, if I'm told in a problem, let's say that the sine of theta equals 0.6, and maybe I don't want to draw a triangle or anything like that, and I'm being asked, well, what's the cosine of that theta? Well, I can use this formula and plug in to solve. Just like I would any other problem. And I'm going to subtract 0.36. I get that the cosine squared theta equals 0.64, so I can say that the cosine of theta equals 0.8. So I can use those identities to help me find out some unknown information. Another example would be if I'm trying to find, using the same numbers, and now I've solved that the cosine equals 0.8. If I want to find tangent, well, I know that the tangent of theta equals sine over cosine. So tangent's got to equal 0.6 over 0.8. And when I do the math out, I find out that the tangent of theta equals 0.75. So I can use these identities to help me solve for unknown pieces without having to draw a triangle. Say I'm given this triangle. And here's my right angle. Here's my theta, which is my unknown angle. And we'll say that this is the square root of 10. This is 3, and this is 1. So I'm given all this information. And the tangent is opposite over hypotenuse, so the tangent of theta opposite over over adjacent is 3 over 1. I can use the Pythagorean identity that 1 plus the tangent squared theta equals the secant squared theta. So if I do 1 plus 3, because the tangent is 3, equals secant squared theta. 1 plus 9. So secant squared theta equals 10. So secant of theta equals the square root of 10. That's another way to use it. You can either draw a triangle or you can use the identities to solve.